Well, welcome back. We're going to continue to talk about some word problems now involving conic sections. Now, this word problem is a very common one. You see a lot of books. It's not too difficult. But what we have is a receiver that's parabolic. Now, a lot of students are a little confused when they see parabolic. Parabolic, what that means is you have a parabola. And a parabolic television dish, okay, so we have a parabola that's created into a television dish. So if you can imagine that, it's not like that. All right. It is 3.7 feet from the vertex, okay, and what's located there is the focus. All right, so if you kind of say that, I'm going to read a little farther. So we're going to find the equation of the cross-section of the reflector. So basically, we're finding the equation of a parabola. That's what it's asking us to do. Okay, find the equation of the cross-section. The cross-section happens to be a parabola, so we're going to find the equation of a parabola. Assume that the dish is directed upwards. Okay, so it's going up, and the vertex is at the origin. That's cool to know. All right, because as we graph this, all right, here we have it, and that's our point right there. Okay, now from here, our equation of a parabola, since it's going upwards, we know that x is going to be squared, and the center, or the vertex, is at 0, 0. So if our vertex is 0, 0, then we're going to have this basic equation, because we know that x, in this case, can be squared, equals 4 times p times y. Well, how do we know that? Well, that is one of the standard equations of a conic parabola. That's what we put it in here in doing that. Now, because it's going upward, x is squared. If it was going downward, or sorry, to the left or right, that would make it different. And then y would be squared. All right, but that's the basic equation we have right now. Now, the next thing is we've got to figure out p. Now, what is p? Well, p is a distance, all right, from the vertex to the focus. It's also a distance from the vertex to the directrix. Okay? The directrix. Now, they're both the same. Okay? So they're both the same. Those distances have to be equal. Okay? Because that's one of the properties that a parabola has. So if we look at our problem, we have a parabolic antenna, which is 3 point from the vertex is located to the focus. That's a key phrase right there, because actually that tells us right here, 3.7 feet. That actually would have to be our p-value. So that's the distance from the center or vertex to the focus. So what we're going to do is we take that value and we plug it in for p, and we get a final equation. So our final equation is going to be x squared equals 4 times 3.7. All right, y, and that would be our final answer. And if you wanted to finish this up, you could have, it's going to be 8, 12 plus 2. What was that? 14.8. All right. 14.8y equals x squared, and you can simplify it that way too. All right. We have another one. All right, very similar. The only thing that has changed in this one is that our distance from our focus is 4.7. Same thing, once again, just a different answer. It's also moving upward, vertex is the origin, so we have x squared equals 4.7 times 4. It's 4p, 4 times 4.7, all right, times y. Taking this is 18.8 y equals x squared. Fill your math, and that's what you got. All right, so once again, understanding the standard form of an equation of a parabola is important. Understanding how to find p and what p is. Key words we're looking for is focus, okay? Distance, located, all right? And all those different things. Because when you're finding an equation of a parabola using conics, key thing is find the vertex, okay? Find the vertex, and then find the p-value, and that's the distance, as we said, all right, from the focus to the vertex and from the vertex to the directrix, okay? Find the vertex and find your p-value. All right. There you go. Go get them.